Hello, myself Kaustubh Dwivedi, and this is the basics of quantum mechanics. We will not go into very basics. Um, I expect if you are watching this video, I expect that you know something about quantum mechanics. This is not a course. This is not a lecture. This is not teaching. This is like discussing. So I will discuss something of quantum mechanics here, uh, and the my goal in this video is to not come out as a teacher. So it is my goal is that this video should not look like a lecture. This should be a discussion, like you discuss with your friends, like that. So it's a very simple. It should be a very simple class. Oh, it should be a very simple video, not a class. No, that's the goal. It should not appear like a class. So, quantum mechanics, okay? So, quantum mechanics it comes in the BSc Physics course, and it also comes in MSc Physics course. Now, when we start quantum mechanics, we start from operators. Before going to operators, we started from Planck's laws of black body radiation. But we are not going to do that. I'm going to make it as it can be understood to a person who knows about quantum mechanics. Okay? So there is a very famous problem in quantum mechanics, and everybody knows this. Let's start from there. Then we'll see where it goes. So the problem is one-dimensional infinite potential well. One-dimensional infinite potential well. Very easy. Not at all complicated. So this is a potential well. Here the potential is infinite. Here the potential is infinite. In the middle, the potential is zero. Now this kind of problem is very basic in quantum mechanics, and everybody knows what will be the energy eigenvalues, what will be the wave function, and how to solve it. Now what we need to find in this kind of question is we need to figure out that this kind of questions, how do we proceed in the very first step, because sometimes the questions can this kind of question can change something in this question. They may change the potential. Now if they change the potential from 0 to something, now we have to solve that potential using Schrödinger equation. Now every potential using Schrödinger equation cannot be solved very effectively or very to the point. So there are certain potentials which can be used. We will find one such potential, and we will try to do it. Let's first do it for 0. Now inside the potential where the potential is 0, it means that the particle is free. Particle is free inside. Now this is 0, this is A. By considering this origin and this A, it means the length of the potential well has to be A. Now this potential well is not a symmetric one, because in the symmetric one, the center lies in the middle. So for example, this is not a symmetric potential well. This is a asymmetric potential well. And everyone knows how the energy is calculated. En is equal to n square h bar square pi square divided by 2 ma square. It's very easy. in that way. This is the wave function. Very simple, nothing complicated at all. Now the question comes in our mind, do we have a condition in which this kind of potentials will always give this kind of values? It means, what I'm saying is, will an asymmetric potential well will always give this kind of potential, or does it depend on the length of the each side, or where the origin is placed? Does it depend on that, or it will give value always like that? Now this kind of question can be solved by using, let's say, we can use a very basic solution where psi is equal to a cos kx plus b sin kx. How did we find this? We found it from Schrödinger equation, by solving Schrödinger equation. Schrödinger equation is h bar square by 2m del square psi by del x square plus vx psi plus e psi. Now in this system v is 0. If we consider 0 to a, in that system this thing becomes del square psi by del x square plus 2m e by h bar square psi, which will equal to 0. Now del square psi by del x square will be equal to, let's say, k square psi, and this is the equation which will give us this wave function. Very basic. Now this wave function will give us these values. How? By using boundary conditions. So what is the boundary condition you have to find? Boundary conditions are psi of 0 must be equal to 0. That implies psi of 0 means in place of x you have to put 0. Now putting x equal to 0 in these two equations, this term becomes 0, this term becomes 1. That means a is equal to 0 in this system. And once a is or 0, we can put a equal to 0 in this equation. So now psi of x has transformed to become b sin kx. b sin kx. Simple. It is not at all complicated. Now similarly, we can also find psi of a. Psi of a also has to be 0. Now what is psi of a now? It means b sin ka has to be 0. Now this term is 0. It means either b has to be 0 or sin ka is equal to 0. So that means let's say sin ka equal to 0. Why didn't we take b equal to 0? Because we already calculated a equal to 0. If we take b equal to 0, this wave function itself collapses. What's the point of calculating? If we consider sin ka equal to 0, we will find a universal solution. That's sin n pi is always 0. That means ka comes out to be n pi. Ka comes out to be n pi. Now what is the value of k? What is the value of k? Here we have assumed this to be k square. It means k is equal to what? Root over of 2me by h bar square. Yes or no? Yes. Now if this term, we will square this term such as k square a square equal to n square pi square. This will give us 2me a square h bar square n square pi square. Now E comes out to be n square pi square h bar square divided by 2m a square. This is a term where energy is calculated, but you can define this as En because energy is dependent on value of n. Is directly proportional to n square. Now what does that? This tells us a very significant thing. This tells us a very significant thing about energy. What does it tell? It tells us that now let's focus on one more thing. Let's say delta En is equal to En plus 1 minus En. Now delta En, okay, this equation you can also write it as this, like this, n square E naught. E naught means what? E naught is your ground state. E naught is your ground state. Now E naught is ground state means what? It's the value of the lowest possible energy state. Now in this equation, in this system, now you can put n equal to 0, but will n equal to 0 give you a value of valid energy? The answer to that question is no, it won't. Now what you can put, which will be the lowest energy, and that energy has to be a finite number, n equal to 1. N equal to 1. Those of everybody who is studying quantum mechanics, they must have done quantum harmonic oscillator. In the quantum harmonic oscillator, our energy comes out to be n plus 1 by 2 h bar omega. In that case, when you put n equal to 0, you have a finite energy, which is the lowest energy of the ground state, or we call it 0 point energy. In harmonic oscillator case, or in a quantum harmonic oscillator case, we can use n equal to 0, but in a one-dimensional potential well, you cannot use that. So now come to this point. What will be delta n? So from this term, you can take out the E naught. You can take E naught common. Now you can write n plus 1 whole square minus n square. These are not at all complicated stuff. I don't know whether I will tell you any complicated stuff today or not. I don't know. I'm just making a video for the very first time, and I really don't know. How much should I say, how much should I not say, or how these videos should be made. I don't even know, to be very honest. I don't even know how long this camera or my phone can record. I don't know what will be the size of the file if I shoot it in 4K. I don't know. I'll just figure it out. So here delta En comes out to be 2n plus 1. Now guess one thing. When n varies, the delta n also varies. Delta n means the difference between energy levels. So this is a one-dimensional potential well tells you that the difference between first excited state and second excited state will be lesser than difference between second excited state and third excited state. Now look at this. This is your ground state, where value is h bar square pi square by 2m a square, which is your E naught. Now for this is n equal to 1. This is n equal to 1. For n equal to 2, where will be the particle? Where will be the energy level? The energy level will be at n equal to 2 means n square equal to 4 So it will be 4 times of the height of n equal to 1's height. If this is x, now we have to do 4x, 2x, 3x, 4x. Here will be the n equal to 2. N equal to 2 will be from here, which is basically 2 h bar square pi square by m a square, which is e equal to 1. E1, which is means fast excited state, and for fast excited state we have n equal to 2. Now the third level will be at it will be at n h bar square pi square by 2 ma square, which is E2. Now this is a very important concept, but this is a very basic stuff of quantum mechanics. Everybody knows this, and this is my first video, so I'm keeping it very simple. Now this is a very simple stuff which we are dealing with it right now. Now in this system, we found the energy, but how did we find this wave function? This is how we find the energy, but how do we find the wave function? Now everybody remembers this is the formula. Everybody remembers, because you have to remember these things so that your questions become faster, and even everybody remembers these kind of formulas. But the important point is, if we don't know how to find it, if in a question where the potential V is something which can be integrable instead of 0, there we will lose our mind ki how will you solve it. So it is very important to know how do we approach to this kind of question, because these kind of questions can be complicated. It can get into some Dirac delta potential, or some attractive Dirac delta potential, or it can be some kind of sec function or tan function, something like that. So these kind of questions have been, sometimes what happens is they'll give you the wave function and you have to find the potential. Those kind of things can be done using Schrödinger. But if they have given potential and they're asking you, find the wave function, or find a relation between some distance and the potential, then those things will get complicated. Now how do we find this? We already found. The point is, we already found psi x is equal to b sin kx. All we have to do is, here k, we have to put the value of k here, and we have to normalize it so that we can get the value of b. So b has to be normalized, or with the wave function has to be normalized. So how do we normalize? We normalize it by integrating it. Now where to where we have to integrate? We have to integrate 0 to a. 0 to a, b square sine square ka, or kx, sine square kx dx equal to 1. Now b square will be common, integration of sine square kx dx 0 to a. Now how will you solve it? You have to convert sine square x into cos 2x, and after doing that you can find it. Now I will save time, so I will do it this way, because I know it and everybody knows it, not just me. So b is equal to 2 by a root over. So our psi becomes root over of 2 by a sine, where is it? Here, k is n pi by a. Instead of kx, we can write n pi x by a. And that's it. That's all. That's it, and that's all. And there can be a lot of different questions on this, and sometimes we can, people can ask you about. So this is the asymmetric potential well. There is also something called symmetric potential well. In symmetric potential well, the energy will stay constant, and but the wave function will change. Now you can see this wave function. Now everybody knows this wave function is a odd function because there is a sine function in it. Now the thing is about sine function is that when you put x equal to minus x, the sign of the wave function changes. This thing doesn't happen in a even function. And when we take a potential which is symmetric in nature, symmetric means this is A, this is 0. So we have to shift it so that both the boundaries will lie at a by 2 minus a by 2. So the origin will be at center. Now that will be a symmetric potential. In symmetric potential, when you put these boundary conditions, you will come out for n equal to, if the n is odd, the function will be even, which means instead of sine you will get cos, because cos is your even function. When n is equal to odd, the function will be even. When n is equal to even, the functions will be odd. Functions will be odd means it will be a sine function. And the energy term will be constant. No change in the energy. So we will, I think I will make another video on that if I get time. And this is my first ever video. I don't know how I have discussed it. Whatever it is, I will try to improve. Let's see how many videos I make. I don't know. I have no idea. Let's see. Thank you. And this is very basic. That's why the thumbnail, basics of quantum mechanics. This is very basic. This is the most basic thing you can know in the application of quantum mechanics. There are more basic things than this, which call operators and all those things. But this is the basic you can get in application way. So those who say it is not basic, it is basics. These are the basics. Thank you.